Hi everybody, I'm Tony E at GRP Interface Brief, and I have an interruption. Okay. So today is day 67 of the 100 Days of Labbing journey. I am not feeling well today. I just haven't felt well for about 2 days. Yesterday I pretty much just laid around the house and had a blanket with me all day, and today I went to bed last night really early, and today I got up late. So something is definitely going on with my body. But I took my temperature and it's stable, but I always feel hot and cold. So I don't know. We're just going to kind of roll with it today. I'm going to do a sort of lab of my own creation today. It's going to be a pretty cool topology I'll build in GNS3, and I'm going to practice the redistribution when we redistribute into 2 points. And I'm going to do it a number of times, and you'll see what I mean when I get into the topology. As well as I'm going to introduce some elements of PPPoE and PPPoE and MPLS LDP, just so I can stay sharp on some of those things. And I guess once we get the complete connectivity established, then we'll go ahead and see what we can lay over top. Maybe we'll put some GRE tunnels or IPsec. We should probably practice IPsec. I don't do it very often. I know it's not a huge section of the lab, but you do have to remain comfortable with the configs, comfortable enough to implement it with all its various options. So. All right, so I'm going to get started. I'm going to make my own lab here in EVNG, which is over here. It looks funny on my preview screen. All right, so let's add a couple of nodes. We're going to go Cisco, IOL. These will make them the router images. R is good, everything's good here. Ethernet port groups, and let's do 1, 2, 3, 4, 5, 6, 7, 8. We'll do 8 of these suckers. So I'm just kind of a little bit making this up as we go, because I think this will enable me to really solidify some of the theories that I've been formulating. If anyone's seen my recent videos about redistribution, I'm pretty close to having a really great grasp on everything that makes it up. And we just do a horizontal align for these. You definitely don't have to do this, but it makes it look nice. And sometimes when things look nice, you just feel good about it. You know what I mean? Like right after you clean your house. Right after you clean your house, you feel good about it. You know, because everything looks nice. Hey Tony, studying for my CCNA. COD dude, what's up, man? Studying for my CCNA. What would be your best advice for labbing? GNS3 or packet tracer or both? Definitely both. You can, I think for CCNA, routing and switching, I think you can do the entire curriculum in packet tracer, and I think you can do the entire curriculum in GNS3. So both will give you great results. I recommend using both so you get more exposure to how the IOSs operate. Now, granted, it should be the commands will be exactly the same. You know what I mean? I say exactly with quotey fingers, but exactly the same meaning show IP route is going to be show IP route on any of the systems. But it just helps you to understand how they interact, the different software platforms, and it'll give you some great experience by bouncing back and forth. Oh, mentors! Hey, good morning. Top of the morning, man. I'm glad to see you on stream today. Joining me on stream today. I've been a couple of streams. Excuse me, a couple of streams without you. And I always worry about you. Make sure you're you're feeling okay. So glad to see you check in on Discord. If anyone wants to, you can join the Discord server, the Land Tamers Discord server. There's a link below. And that's where we get our daily chats and share ideas and lots of fun community stuff going on. So there's a link below. It's free to join. Some days are more active than others. Just depends what's going on. And I would tell you there's been many times where people in the Discord have helped me out on problems, and I love when I'm able to give feedback and help others with problems. Real problems, not just a, hey, how you doing? Real networking problems, I should say. And it has definitely been very beneficial. And some of the people that I've met there, and some of the people that I've met in the Discord, I've met in real life. We went to Cisco Live together and had a little group, and it was a lot of fun. So if you have the opportunity, join the Discord server below. You never know when you're going to meet these people in real life, and definitely beneficial. Trust the process. Hey, glad to have you on stream today. It says, try to type show run interface gig00 in packet tracer, and you will tell me. I sense a bit of sarcasm there. Are you telling me that command is unavailable or the results aren't as we would expect? So while you guys are working with that, I'm going to go ahead and connect these guys. Let's see, how do I want to connect them? That's really crazy that it's doing that. There we go. I'll put the 0 zeros next to each other, sort of north-south. Excuse me, guys. I am not feeling well today. I don't know how long I'm going to go for a stream, but I definitely want to get practice in. Look, I'm wearing my my lab everyday gear, and you got to stick by it, even when you're not feeling well. You know, you got to get out there and lab every day, even if it's just something small. You know. So that's what I'm doing. I'm out here not feeling well, but I'm gonna give it a go anyways. All right, E01, E01. I think we can do E01 here as well. And we'll probably do 02 between the middle there. So I'm a fan of even G. Even G. Yeah, man, definitely lab every day. I got to get some 100 days of labbing shirts. I'm here on working in even G. It's primarily where I do most of my labs. And that's because I find it a little bit better interface for building large labs. For CCIE level labs, typically, from my experience, there are 10 routers and 4 switches on basically every lab from any vendor out there. And it just has a really good interface, allows you to use real Putty. GNS3 does as well, I guess. GNS3 has really made some great strides in sort of virtualizing networking simulation. A long time ago, I say a long time ago, but the community moves so fast. But I was going to say, actually, not that long ago, GNS3 wasn't really a great product and didn't support a lot of things. And so that's why, you know, a lot of folks who were studying for like CCIE really couldn't use it. It really didn't support a lot of the images. Even though I used GNS3 all the time early on, just because it's easy, man. It's so quick and simple and easy. So, but as I progressed to my CCIE studies, I needed a lot of the topologies that I was using just required a little more, and it just naturally gravitated over to even G. Now, I'm sure there are a lot of great people who have made great material for CCIE level stuff in GNS3. It's just not my preference, you know. It's just a flavor, right? We have like 3 main things we can work with. There's Viral, Cisco Viral, GNS3, even G, and I guess Packet Tracer as well. Packet Tracer won't work for CCIE stuff. But So there's three main flavors to choose from. I did viral a few years ago, and it was a terrible product then. And I know they've made a lot of great improvements, but it's just not for me. That's all. I really like the look and feel of sort of GNS3 and EVNG without all the overhead. And in viral, there's a little bit of overhead. So it's just my opinion. I'm not a fan. GNS3 is great, but you'll see me do most of my labs in EVNG. But for CCNA level stuff, Packet Tracer for the win, man. It's lightweight. It can run as like a single executable, I think. You might have to run an installer, but you can take it like anywhere. You know, you don't have to bring images with you and GNS3 and installation package and everything. You can take it anywhere. So definitely. Let's see. Trust the process. Hey, great to have you on stream today. Type run. That was my chapter last week. PPPoE, GRE, and some frame relay. Very cool. What does the keyword call in really do in PPP? I'm not sure I've seen that. I don't have a ton of experience in PPPoE, or PPP rather. So let me look it up. PPPoE, or let's do PPP call in. Oh, chap call in usage. Okay, call in, call out, call back. We can take a look at these. The initiating router does not challenge the router it's connected to. Can someone please explain how PPP authentication chap call in is working exactly? I read through the Cisco documentation but didn't find any useful information. This is INE's blog here. I'm going to post a link here. I realize I didn't read these, so I can't validate them. But I'm just going to post them here in the chat in case they're helpful for anybody. I'll keep these tabs open, but I'm certainly not going to sit here and read through it while live. You guys can do that. All right, my lab. So let me kind of scope out a little bit what I'm thinking I'm going to be doing today. Okay, so what I'm going to do here is, this is going to be RIP, and then I'm going to do bright green. This is going to be OSPF, and I'll do this pinkish color. This is going to be EIGRP. And so my prediction here is actually that if we follow the same guidelines that I've used before, which is the sort of dual, I guess the mutual redistribution, what we're going to do is we're going to redistribute here on this router. We're going to redistribute here on this router. We're going to redistribute here, and we're going to redistribute here. And so in previous labs, I had done topologies where I had two routers and something else, and where we would do redistribution here and here. So basically, I'm doing that same thing, except I'm just sort of extending it a bit, right, into another routing domain. That's what I'm doing here. And so the prediction I want to make, let me clear the screen off, is I think that this is going to be the prefix we want to watch. And I think that routers in the OSPF domain will try to reach this network segment via EIGRP. Right? And that comes down to, right, administrative distance. Right? We kind of been through the redistribution lab before. When OSPF learns the routes from RIP, or rather gets redistributed into OSPF from RIP, OSPF is then going to redistribute into EIGRP. If we follow this line at the bottom, RIP is going to advertise it to router 6. Router 6 is going to redistribute it into OSPF. OSPF is going to advertise it to router 4. Router 4 is going to redistribute it into EIGRP. EIGRP is going to advertise it around and around and around. And when it gets over here to router 3 is going to think, hey, the best path to reach this prefix over in the RIP domain is actually going to be my EIGRP route. Right? It should. That's my prediction. It should reach the EIGRP because EIGRP out of the 3 routing domains has the lowest administrative distance. So that's what I think. That's going to be my prediction. Let's see. At Jamie, for directly connected serial doesn't really work as expected. Trust the process. You talking about in Packet Tracer? It doesn't work as expected in Packet Tracer, or outside in GNS3 or others? Oh, also Tony, how do you inject only the default BGP route into an EIGRP domain? How to inject only the default BGP route into EIGRP domain. So, trust the process. Wouldn't you just do redistribution and redistribute with maybe a route map and a matching prefix list? I don't know. That, I mean, off the top of my head, that's what I would think you would do. Right? Redistribution from BGP into EIGRP, excluding all routes, but permitting only the default route. I assume you probably have tried something like that, so maybe that doesn't work as expected. Maybe there's a caveat there. I'd love to try it. Maybe I'll try it with this lab. In fact, I will. I'll try it on this lab, okay? Definitely. In theory, it makes sense. Yeah, we shall see. Prefix list and redistribution, that into EIGRP, that would be how I would be doing it. Yeah, that's, I mean, off the top of my head, that's what I'm thinking. But I tell you what, I'll get to that. Let's definitely do that because I'm not sure. And I guess I could just clear this like this. Boom. Okay, so back to it. This is RIP, OSPF, EIGRP. And I think what we'll do here is maybe we'll make a, maybe we'll do BGP here. And we'll redistribute a default route into EIGRP and kind of see what happens. No trouble. We'll change that on the fly. Did it with redistribute BGP AS metric type, but it's not injecting all the routes. I only need the default. Yeah, I think so. I think this is, we can definitely do this. So let's dive in. So let me just outline this in case anyone is watching at a later date. I don't have IP addresses configured yet. What I typically do for IP addressing when I'm making my own labs is I do 10.1.x, y.x, or y. And what that means, this is x is going to be the router number of the lower number. This is going to be the router number of the higher number, and then this is going to be one of those values as well. So for example, between 7 and 8 right here, it's going to be 10.1.78.7 for right here, and .8 for right here. Right, and that's how I'm going to go through and IP address all of these. So that's just typically how I do it. It just makes it easy for myself, and off we go. You know what? I think I need to do this on all of these routers. Yeah, so for when I'm working in EVE-NG, whether I'm doing my own lab or I'm doing some of Cisco 360 labs or if I'm doing INE material, I use regular Putty. I use regular Putty because in the CCIE lab, you have to use regular Putty. There is no multi-tab Putty, there's no secure CRT or anything. So like I said, I talked about this early on. I want as authentic experience, authentic practice that I can possibly get. And one of those practice points is like window management. I mean, as simple as it sounds, but how do you deal with it when you have 40 terminals on the screen? That takes some practice and some organization, so you don't get overwhelmed when you're sitting at the lab. And so that's why I just run Putty natively here, even though it's really messy, and that's just what I go with. Okay, so we're going to do interface ETH00, IP address 10.1.112.1. Interface ETH01, IP address 10.1.1.3.1. This is the boring IP addressing part. So I'll go ahead and turn on some music on stream. It comes in a can anybody out there let me know if this music when I turn it on is too loud or overpowering? I think last stream it was overwhelming. Host name, what are we on? R7. All right, interface ETH00. Uh, 78.7. .1 57.7. All right, that should do it for that. 7.8. We'll do number 6. iTerm2 for Mac. Yeah, I don't use a Mac. I use a Microsoft Surface here. I've been using this now for about 3 years. I really enjoy it. I think a lot of people use iTerm2 for Mac. All right, this is router 6. Interface ETH00. IP address 10.1.5.6. That's 6. And what the heck am I doing? No shut interface ETH01. I'm router 6, so I need to do IP add 10.1.68. That's 6. And interface ETH02. IP address 10.1.46.6. Alright, looks good, looks good, looks good. Next one, number 5. Putty, interface, host name R5, interface ETH00, and that's going to be 5 and 6, IP address 10.1.56.5. Interface ETH01, and that's going to be IP address 10.1.57.5. And interface ETH02, IP address 10.1.35.5 between routers 3 and 5. At this point, I should have some sort of reachability here. Let's just try. Let's see what we get. Let's see. Of course, iTerm is a no-go for a Surface. Don't know if you see the above. You had a lock. You had a look at. Have you had a look at Solar Putty? It seems to be a bit cleaner with the new tab structure. Tmux works nicely as well for Linux. Again, depends on preference. I have seen Oh, what happened? Did I crash this thing? Show adjacency. All right. C's 5 and 7 doesn't see anything upstream. That's perfectly fine. Let me hop here on 7, do the same thing. I have seen a couple of folks using, what do they call it? Solar putty? What the hell do they call it? Yeah, solar putty. And I think it's just sort of a way for SolarWinds to rope you into their entire ecosystem, right, of GNS3, and then using their own terminal. I don't know. I think it looks a little junky, but then again, I'm in love with like traditional putty, so I guess I'm probably the junky one. Let's see, router 7 should have 2. Okay, looks good. I'm just going to check router 8, then we'll move on. All right, looks like 7 and 6, looking good. Okay, so let's hop over to, let's see, we got 1, 2, 3, and 4 left. Let's do 4. Okay, enable conf-t. Hostname R4, interface ETH00, 34.4, and no shut interface ETH02, IP address 10.1, 46.4. No shut. Interface ETH 01, IP address 10.1, 24.4. Oh, ambiguous command. Okay, looks good. That's 4. We'll do 3. See, where's 3? 3 is there. Interface ETH 02, IP address 10.1.34.3. Interface ETH00. Wait, that was incorrect. Sorry. ETH02 10.1 35.3. Interface ETH00. IP address 10.1.34.3. Interface ETH01. IP address 10.1. Let's see, 1 to 3 to 3. Okay, just a couple more. Cali fanboys and arch nemesis. Yeah, I've been waist deep in Cali for like the past 2 weeks. Just the way it is for work sometimes. I think really I'm kind of fortunate in that regard that that I get to do such a wide variety of things at work. I really don't do a lot of routing and switching every day. You know, only occasionally is my routing and switching knowledge put to good use. ETH00, address 10.1.2.1. But yeah, sometimes I gotta dig into working with Cali for a couple of weeks, setting up some backdoors and stuff for different VMs and having fun. It's great. It's a learning experience. It's It's a lot of fun. I also have a history of it, so I'm not too far out of my element when I do it. It's just like a refresher, you know what I mean? All the time I'm looking something up in online and like, oh yeah, that's how you do that. You know, it's just something you've done before but haven't done in a while. So, all right, Control 666. I'm trying to make my body sit up straight so my back doesn't hurt. Come on. Oh, here we go. All right, I just want to do show adjacency. 2 and 3 looks good. Let me get on 4 and 3. I'm just doing a broadcast ping, which should send a ICMP echo request out all interfaces, and then I do I like to do a show adjacency, and that should give me my layer 2 and 3 adjacent neighbors. Except I don't know. This is sort of lagging a little bit. I'm using this EVNG from, it's hosted locally. I'm downstairs on an old PC that I call a server. It's not really a server. But it's running ESXi, I don't know, 6 or 6.5 or something. Come on, Control 666. There we go. It's a tried and true method. Okay, 4, 1, and 5. That's exactly what I wanted to see. And then 4. Normally this does not. Normally it's a pretty quick thing to do, but I'm hitting Control Shift 666. You guys can't see it on the screen, but wasn't canceling out. All right, show adjacency. Good. Okay, so now we should be able to quickly implement our routing protocols. Let's start with our what are we on? Router 4. Router 4 is going to have OSPF. So let's do which interfaces? Interface ETH 02, IP OSPF 1. We'll just call it area 0. That's fine. And interface ETH 01, IP OSPF 1 area 0. All right, next I'll get on to router 3 and get on its interface ETH 02, IP OSPF 1 area 0, and interface ETH 0, INE. Interface ETH 00, IP OSPF 1 area 0. We should see an adjacency come up. Show IP OSPF interface brief. All right, I got my 2 interfaces, ETH 00 and ETH 02. Okay. Router 4, do show IP OSPF interface brief. Oh, and there's my problem right there. Okay. Interface ETH 01. No IP OSPF. Instead, it's interface ETH 00, IP OSPF. Process ID 1, area 0, and we should get an adjacency. Hey, mentors, clogging up the pipeline here. Let's see all the chat. Everyone has their favorite tools. Yes, yes, yes. Being purple team has its advantages, my man. Definitely, man. I was at B-Sides DC on Friday, local DC B-Sides conference, and I participated in the OpenSock.io Blue Team CTF, and it was an amazing, amazing, amazing experience. I really had a lot of fun. I'm going to do a short video on it, on that experience, and post that maybe tonight. It was a seat that I don't normally get to sit in. I'm using sort of a metaphor there, maybe not a metaphor. A seat I normally don't get to sit in. I normally don't get to do SOC operations, right? I don't do operations, I do engineering. I work with the security tools, I install them, I stand them up, I try to work them into networks for solutions, right? That's my job. But not all the time do I get to sit in the hot seat, so to speak, and actually become an operator and try to hunt and find things going on in the network with a given set of tools. And although I'm familiar with a lot of the tool names and what they do, I haven't ever actually used any of those tools in operations, and it was a ton of fun. It was a ton of fun. Was this a team engagement or you were solo CTF? Joes versus Blows. They had a Joes versus Pros there. That was next door. So Joes versus Pros was there, and also what I was doing was there. What I was doing, you could enter as a single solo person, or you could enter as a team. For me, I was there with a buddy, so it was the two of us, and we placed 13th out of 41 teams, which was really cool. Yeah, we placed 13th. We got a ton of flags. I think we got like 60-some flags. I think we got like 60-some flags. It was a lot. Man, it was a huge environment. There was only 2 teams that completed the entire CTF out of 41 teams. 2 teams completed it, and they both completed it within the last 10 minutes of an 8-hour shift. So at the end of 8 hours, we probably had more than half the flags, I think. We had more than half the flags, and we were in 13th place. So there were 2 teams that were just skyrocketing, man. They were just doing awesome. I think one of them was a solo person, and the other was a team of 2. So it was a really, really awesome experience. Check it out. It's on opensoc.io. I'll pull it up here. Ton of fun. This is it here. Your incident response team, ready for worst case scenario. Are you? Really, like, here's all the products they use. It was Graylog, Metasploit, Suricata, PFSense, Moloch. I didn't see OpenSense in there. This is Elk. Collide was very cool. Snort runs inside of PFSense. What was this one? OS Query. That's right. OS Query was with Collide. Graylog was our SIM. It was really, really awesome, and it was very cool. I had a blast, and I'll do a separate video about that. Hackerman was there. we watched the Hackerman videos, if that's what you're talking about. They had a projector screen up, was showing a bunch of stuff. All right, anyhow, let's finish putting some routing protocols in here. I need routers 5 and 6 to finish my OSPF adjacencies. Enable CompT interface ETH02, IP OSPF1 area 0, IP OSPF1 areas. I'm not in an interface, that's why. I'm like, why isn't it taking the command? Interface ETH02, IP OSPF1 area 0. We should see an adjacency, that's good. Router 6, same thing, same command, same spot. ETH02, IP OSPF1 area 0. We should see an adjacency, looks good. All right, now let's hop over to routers 1, 2, 3, and 4 into our EIGRP. So here's one. And should we do named EIGRP or classic EIGRP? Anyone can say so. You want to do half and half? I got 1 vote for classic. All right, I'll do the first one, classic. Router EIGRP 100. Or what routers are these? 1, 2, 3, 4. Let's do network 10, 1. What were our networks here? 1, 2, .0, wildcard bits, and then also we want to do 1, 3 with our wildcard bits. You know what? I'll also we'll do no auto summary. And what else? Flip a coin. I don't have a coin, but we'll just do half and half. Router EIGRP. Okay, that's that. Let's get over on router 2. We'll do evens get named, odds get classic. Let's see, just to make it painfully impossible to remember. Router EIGRP, and we'll call this lab 1 2 3 4. Address family IPv4, autonomous system 1 2 3 4, and we'll do I think that's in topology base, no auto, exit, network, and what are we on? Router 2. So router 2 is going to be 10.1.12.0 as well, and some wildcard bits, no problem, and then also network between 1 and 4. So 10.1, 114 wildcard bits. Okay, that should be it for that. Now we'll do routers 4 and 3, and we should see EIGRP adjacency. I said evens would get the named, so router EIGRP, EIGRP, lab 1 2 3 4. Address family IPv4, autonomous system 1 2 3 4. Topology based, no auto. Oh crap! I forgot. Do I have a meeting? Topology base, no auto, exit. We'll do network, and we're on router 4, so we want to do 10.1.140. 255, we should see an adjacency there. I'm very surprised we don't. Because I did the wrong. Got it, because I did the wrong network. Do show run section router EIGRP. My phone is hopping and popping. Let's see what's going on here. Alright. What I like to do is I like to highlight the whole thing, paste it in, Control A, no, and then I can just start fresh. And that's just a quick way that I can get to something that's sort of a nested configuration. I would have thought I would have seen an adjacency. What have I done on router 2? On router 2 I did the same thing, same problem. Yeah, show run section router EIGRP. I made the same mistake. So let's see if we can grab this. Comp T. Control A, no, and we'll take that element out, and then we can just fix it up here. Do Control A, DD, boom. There's lots of cool little keyboard shortcuts that that help with adjacency. Okay, next one is router 3. Enable comp T, and this one is going to be classic EIGRP 1 2 3 4. No auto, and we're going to do network 10.1.130. And I think this is, oops, this is its only adjacency. Okay, it has an adjacency. So right now we should be able to see right now on router 3, we should be able to see this link because it's connected, this link via EIGRP, and this link via EIGRP. Yeah, so these should come in as these for Dijkstra, and this should be a C for connected. Now let's do that. Show IP route. Show IP route EIGRP. Yeah, I see the two links. Very good. And then, of course, we have the directly connected link. So. All right. Didn't on router 3 I already did OSPF. Show IP route OSPF. Okay, because those two links are connected. Two of its OSPF links are connected, but the other one is learned there. So let me pull that up on the drawing. So here on router 3, I'm looking at OSPF, and we know OSPF, which we highlighted, is going to be like this. So right now in OSPF, we only see this link with an O route because this one and this one are connected. So that makes perfect sense. Now we just have to do the RIP routing domain. Which is going to be on routers 5, 6, 7, and 8. Oh, I have to check my messages. Hang on. Can someone remind me at 10 a.m. I have to do a call? Yeah, at 10 a.m. I have to do a call. Someone needs to remind me. All right. Router 8. Enable conft RouterRip. We're going to do version 2. Again, we'll throw in some no auto, and we'll do network, and it's just sort of classful. Router 7. RouterRip, no auto, version 2, network, and it too is classful, and then we need to do 5 and 6. 6 conft RouterRip, version 2, no auto, and network 6 and 5. RouterRip, no auto, version 2. Oh, a mentor, sorry, I just had something pop in my mind. I did not get a new chair. I'm still with this crappy old chair that I have. I took the arms off of the chair, so now it's just like I threw them suckers away, just so I'm not using them to rest my elbows. It just gives me a little bit more freedom, but 10 a.m. Got you. You're an hour behind me here at 9:40. I got 9:40 here too. What do you mean, mentors? We're on the East Coast. Anyhow, I was getting distracted, but no, I never got a new chair. All right, show IP protocols. I want to see RIP. And I'm going to not send RIP out this interface. So, passive interface. And I think that's going to need to be on number 6 as well. Now if we do show IP protocols for RIP, it's only going out the 2 interfaces. I think it will still include that network, though, that upstream network, in its All right. No, sir. I'm an East Coast man. East Coast, Mid-Atlantic region. Okay, so at this point on router 6, because it sits in between two routing domains, should see all of the RIP routing domain and all of the OSPF routing domain. So let's do show IP route. Okay, we get to see a lot of upstream and downstream stuff. Show IP route OSPF. Okay, from router 6's point of view. Yep, that makes perfect sense. Okay, okay. Okay, sorry, router 6. I'm just trying to remember where router 6 is. So it's saying 3 and 4 and 3 and 5. Looks good. And show IP route RIP. It sees 57 and 78. That's right, because the other ones are connected. Okay, very good. And I'm going to check on router 7. I bet router 7 is seeing one of the prefixes it should not, is my prediction. Let's see if I'm right. So the RIP, so I'm not doing any redistribution at this point. These are only the prefixes within the native routing protocol. And yeah, so we should not be seeing 46, and we should not be seeing 35. We should be seeing 56, 57, 68, 78. We should be seeing the rest of those, but not these two. And let me pull up the whiteboard to kind of walk through what I'm talking about. I predicted these would be in here, and I'm glad to see that they were. Sort of reaffirms, you know, what I was thinking. All right, let me get rid of some of this. And what are we going to do? Hot pink? Pink, I guess. All right, this is RIP. This is OSPF. And let's say we were on router 6, but tell you what, let me see if, yeah, we'll do router 6. Okay, sorry, I got a conversation over here on the phone, and I'm trying to not get too distracted. Anyhow, so when we enable RIP here on these 4 routers, router 5, router 6, router 7, router 8, we're using the network 10.0.0.0 classful network statement. And because, for example, on router 5 and 6, it has 1, 2, 3 interfaces and 1, 2, 3 interfaces, when we use this command, the network command, it actually pulls in this network, and this network, which is why here on router 7, we got to see this link and this link because they're upstream. Because from router 5 and router 6, they both think, hey, this interface is within my classful range. I can include it in my RIP announcements. So I'm trying to think, how can we sort of filter that out? I guess we could throw on a distribute list. But that might break something, what I'm thinking, a little later on. Hey, Jamal. Hey, Tony. How's everyone? Thank you for sharing. Yeah, I appreciate it, man. Thanks for joining me on stream today. I really appreciate it. If anyone else is out there in the chat, feel free to say hi. So I think everything is working as it should. Now I need to do the redistribution to go from RIP to OSPF. And I'm trying to think, are there going to be any caveats with that? There are, right? We're going to run into the problem of a redistribution sort of loop, where I think what we're going to see is some unexpected behavior. Hey, this plus that. Hey, good morning. Glad to have you with me on stream today. Just doing a sort of lab of my own creation here. It's going to be pretty fun. But I'm not feeling well, so I'm getting distracted. So let's see, routers 5 and 6. 5 and 6 are going to be our autonomous system border routers, which are going to be redistribution points. So let's see, on routers 5 and 6, I'm in RIP protocol, RouterRip. So we need to redistribute OSPF. So let's do redistribute OSPF. Our process is 1. And you know what? I think if we just hit enter, it will automatically include internal and external routes. And we can check that by doing do show run section RouterRip. Maybe I have to do show run all and do begin RouterRip. Yeah, so if I do the show run all and begin with the RouterRip stanza, here's redistribute OSPF 1. That was the only command that I entered. Metric 0, and then it's going to match internal, external type 1, external type 2, NSSA type 1, and NSSA type 2. So what we do need to do is set a default metric value, or else it won't be in there. You need a coffee. I do have my coffee with me, but I'm just not feeling well. All right, so anyhow, so at that point, router 7 should see prefixes that are within the OSPF domain, right? Because now we only have one point of redistribution. So if we take a look here on router 7, we should see, we already saw this link. I'm going to highlight them all in black, the links that we've already seen. Previously, we did not see this one. I believe now we are going to see this one, which is 34 as the third octet. Let's get on router 7. Here's our existing routing table. We did not see 34. Let's see if we can see it now. Show IP route. 34 should be the only added prefix to this list. All right, good. So that was router 5. Let's do router 6. Now, currently we're only doing one-way redistribution, which means I'm only bringing in OSPF into RIP. I'm not bringing RIP into OSPF. That's where the loops are going to start, right? At this way, when we're just doing one-way redistribution, all we're doing is we're giving the RouterRip, the RIP routing domain, a view of the routes that are in the OSPF domain. But right, we don't exactly have full connectivity. I can't ping from a RIP domain to an OSPF domain because OSPF doesn't know how to get back to the RIP domain. So the pings will go from router 7 on out, but they won't know how to get back because those target routers won't have a route back. So here under RouterRip, let's do redistribute OSPF 1, and remember we have to set a metric. And again, so this is just giving us 2 redistribution points, which should be pretty good. All right, so now to bring in the routes the other way, to bring them from RIP to OSPF. And I think we're going to have a looping problem, but I kind of want to leave it alone and see what happens. Router OSPF 1, we're going to do redistribute RIP. And we want to do subnets. And I think that's all we need to do for that. Now I'm going to do it on both router 6 and 5 because they are our autonomous system border routers. Redistribute RIP subnets. Okay, so if I'm making a prediction, right, which is what I'm going to do as sort of steps throughout this entire lab. Just trying to erase this whiteboard. Okay, so previously we redistributed OSPF into RIP and OSPF into RIP. Router 7 and router 8 could then see this prefix, right? They could always see this one and this one because they were part of the RIP routing domain because we didn't filter them out. Okay? So we could see this one. But if router 7 tried to ping maybe this interface or maybe this interface, it would send the ICMP echo request but would never get an echo reply because router 4 and router 3 did not have a route back. So what we just did was did a mutual redistribution on routers 5 and 6. We did RIP this way and OSPF this way. RIP this way, OSPF this way and RIP this way. So this is RIP, this is OSPF, which means routers 3 and 4, which are part of the OSPF routing domain, right? If we draw it, it would be like this. The OSPF routing domain. These interfaces should now be able to see this link. Well, it should be able to see all the links now, right? So this is going to be 57. Between 7 and 8 is 78, and between 6 and 8 is 68. So now let's get on routers 3 and 4 and verify that we see these 3 networks now. All right, that's 5. I wanted to get on 3 and 4. Here we go, and now we can see that they are the E2 routes, right, which are the external type 2s, which is whenever you redistribute from a protocol into OSPF, by default it is going to be OSPF external type 2. You can change that by using a statement in your redistribution command under the OSPF stances. So when you say redistribute RIP subnets, and then you, by default, it's going to call it external type 2. In fact, you can change it to external type 1 as well. And what that does is that affects the metric calculation, right? All E2 routes have a metric of 20 that stays metric 20 throughout the entire OSPF routing domain. Even if we have multiple areas, it will stay 20. If we use an external type 1 route, that metric value, just like all the other OSPF routes, will increase its metric via the cost as it traverses the links. So let's get on our redistribution points, which, for example, in this topology is router 5, and do show run section router OSPF, and we're doing redistribute RIP subnets. But if we do show run all, begin router OSPF, here is the same RIP command, redistribute RIP metric 20. It gets defined that by default, and metric type 2 by default. So this command is actually running in the iOS, even though I didn't type it. All I typed was redistribute RIP subnets. It goes ahead and puts the rest in there by default. Anytime you want to check what is a default config, typically you would do show run, right, section router OSPF, but that doesn't show you the complete view all the time. Instead, that only shows you what is the not default, right, or it turns on a feature, right? Redistribute RIP is not by default, so it's showing me that. Subnets is not by default for that statement. But if you want to see what's really going on, you do show run all, and then whatever you're looking for. The section doesn't work. Oh, it proves me wrong sometimes. I haven't gotten section to work all the time when doing show run all, which is why I do the begin statement. But anyhow, if we scroll down to the next page, here it is here. So there's a lot of commands here under the, if I increase the size of this window, look, under the router OSPF, there's a lot of commands that are turned on by default that you don't see when you do show run. And that's because those are there by default. Now, when you do a show run, all it's really showing you are the things that are not default. So when you do show run all, you're getting the complete view of the running config, including all of the default settings, which is why I lean on it a lot. It's especially helpful when trying to figure out what are timers, you know. The queue depth update 200. How about this? Timers throttle. If ever there was a task in a CCIE lab, throttle your shortest path first timers to half of default, right? That would be like the type of language used in a CCIE lab. First of all, you're thinking to yourself, what are they by default? You don't know what they are by default. So here's how you find that out. For me, I always do the show run all, and I'm taking a look at these values, and I'm going, oh, okay, by default, it's 5,000, 10,000, and 10,000. So I know that would need to be 2,500, 5,000, and 5,000. Right? That's how I use it. Being able to write on the screen is pretty useful. Yeah, I got the Surface Pro, and I'm really happy that I have it for many reasons. I've had it now for about 3 years, and writing on the screen has been very helpful. I've given lots of demonstrations and taught a lot of classes and stuff, and it's like a digital whiteboard. You know, it's awesome. Anyhow, guys, it is 10 a.m. I have to hop on a call real quick, so I'm going to leave the stream running. I think I'm just going to mute the microphone and put up my my Be Right Back window, and I'm going to hop on some headphones. So I'll be back probably in about 15 minutes, maybe less than that. But I just want to let you guys know I do have to take care of something. So we still have to finish the redistribution for this lab. We still have to finish the redistribution for this lab, as well as lay in a bunch of other stuff. Uh-oh. My screen went black. I don't know what happened. I'm sorry if you guys can't hear me. Let me know if you can hear me. I have no idea what just happened. My entire screen went black. I lost myself. Yeah, I lost myself. Okay, you hear me? Cool. All right, guys, I'm going to leave the stream running, but I'm going to step away for a minute. If I can bring up my whiteboard again. I'll see you guys soon. I'm on mute the whole time. It'd be nice if someone told me I was on mute. How's everybody doing out there? I'm getting ready to come back live online, finish up this lab. Let's see. This would be fun to download via stream and do a little editing of the convo just to make a lulz meme. Sorry, I'm in one of those hacker modes. Are you going to do like a bad lip reading video of mine? Is that what you want to do? Like the football bad lip reading? Those are always really fun. Oh my God, guys, I have a terrible headache, but at least my body temperature is somewhat regulated. I don't know what's going on with me. I am not feeling well at all. Not feeling well at all. My coffee's cold. Ugh. All right, let's get back to it. Here's where we left off. I'm going to shrink this this window back to somewhat normal size. Excuse me. And I think where I left off, we already redistributed OSPF into RIP and RIP into OSPF. And so let's see from router 3 and router 4's perspective, how can it get to that show IP route? How can it get to that 78 network? It looks like it sees it router 3 via router 4. Okay. And router 4, which is here, show IP route. Hey, I'm going to turn the music back on, guys. Router 4, seeing it via 4.6. Okay, that's very interesting. Does everyone see what's going on here? Let me bring up the whiteboard session. Erase all of this crap. Erase, 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 erase. Okay. This is RIP. Okay, so what's happening here is I've drawn it a couple of times. We're doing RIP into OSPF. We're doing OSPF into RIP. OSPF into RIP. And here we're doing RIP into OSPF. On router 3 and router 4, to get to this network, which is 10.1. Maybe you can't see that. It's underneath my my video. 10.1.78.0 is this network here. To get to this network, router 4 goes this way. Router 3 goes this way. All right, isn't that interesting? Wouldn't you think that router 3 going straight to router 5 would be the better path? So I think we'll show that. So again, here's router 4. Show IP route to get to 78. It's going via router 6. Now router 3 to get to 78 is going router 4 by way of router 4. It's not going directly over to router 5. I think that's pretty interesting. So let's get on router 5 and see what router 5 sees. Show IP route. You see what's going on here? Look at router 5. This is the most amazing thing I've ever seen. I mean, this is absolutely one of the reasons why I sort of, love routing and switching so much. Well, I guess there's lots of reasons, but. Router 5, in order to get to the 78 prefix, is going to router 3. Let's show this over here. That's the wrong one. Okay, so router 5, in order to get to this network, it's actually going to router 3. Now, how crazy is that? Isn't that absolutely insane? I mean, it makes perfect sense based on the behavior of the routing protocols. However, I think it is sort of counterintuitive to what you would expect, right? You would expect that router 5, that this prefix 10.1.78.0 is only one RIP hop away. But what's happening here is router 6 is redistributing RIP into OSPF. OSPF is sending those LSAs up and around and up and around. Remember, router 5 is participating in OSPF. So router 5 sees this prefix via OSPF, which has an administrative distance of 110, right? I'm dealing with default administrative distances, while the RIP prefix has a default administrative distance of 120. So when it receives the route, it's going to install it as an OSPF route, which means it's actually going to take, if all these are equal bandwidth and equal delay and equal cost links, it's going to be sort of suboptimal routing, right? It's going to pass through 3 additional routers that it shouldn't. I think that is very, very interesting. Okay. So I'm going to leave that alone. So actually, I know how to fix this problem, but I'm actually going to, I know how to fix this whole problem right here. Let me do it in red, because I freaking love red. I know how to fix this whole problem right here, but what I'm going to do is I'm going to move this way, and I'm going to start to do the redistribution statements here. OSPF here, EIGRP here, and again, OSPF here, and EIGRP here. And I kind of want to see what the whole topology looks like from this prefix and this prefix, right? I kind of want to see what is the path that is going to be chosen. And then I want to go through and fix each redistribution loop. Now, does that look crazy enough here? There. Now she's beautiful. Okay, so that's going to be routers 3 and 4. Let's see what routers 3 and 4 look like. For 78, okie dokie. And then for EIGRP, show IP route EIGRP. It sees that this is going to go via router 1. And via router 1 for all routes. Now, if I go over to router 4, it should be the same thing, but sort of in reverse. Show IP route, EIGRP. I forgot the no IP domain lookup. And the same thing here from router 4. In order to reach any of the other prefixes in the EIGRP routing domain, you must send them to router 2. This makes perfect sense from router 4's perspective. All right, let's do the redistribution here. So I guess what I'm showing here is that router 1 and 2, which are only in the EIGRP routing domains, if I show the routing table, they should only see what's in the EIGRP routing domain. That's router 1, and here's router 2. What we're going to see after we do the redistribution, we should see everything from the OSPF routing domain and everything from the RIP routing domain, I believe. Now, I think we might have to include some externals. I'm not sure. We'll see about that. Okay, so our redistribution points are going to be router 3. So I'm going to do config T. And this is classic EIGRP. So let's do router EIGRP 1, 2, 3, 4. Let's do, first let's do default metric. I'm going to call it, that's not what I wanted. What am I thinking? Default metric. Here we go. I'd like to do 1,100, what is it? 255, 1,500. So now I don't have to worry about applying that metric in each redistribution statement. Now I can just sort of blindly do redistribution. All right, redistribute OSPF, process ID 1. And we already have a metric, default metric established. So let's just hit enter on that. Let's see what happens. Wow, okay, so on router 4, so let me just quickly show on the whiteboard. Oh, guys, I don't feel good. Quickly show on the whiteboard what we did. I was just here on router 3, and I just redistributed OSPF into EIGRP. And then I came over here on router 4 and did a show IP route. Okay. And I get to see all of the prefixes from, actually, I don't think I saw this one because it's going to be directly connected. All of the prefixes between all of the routers. So this is going to be 35, 56, 57. Let's just verify them. 78. Because I'm trying to make predictions here. And by making predictions on the behavior of the lab is going to help solidify for me, for myself at least, that I understand the behavior and that I'm able to look at this topology, understand the interaction of the routing protocols, and be able to predict the behavior even before it happens. So we wanted to see these here. So what do I see here? I see, wait, from router 4, show IP route EIGRP. I would have expected to see some EIGRP prefixes. Let me see here. Show IP route. Okay, I see externals here. Let me get on router 2. I see externals. In router 4, I don't see externals. Wow, hang on, this is kind of throwing me for a loop. Why don't I see the externals here between router 2 and router 4? Show IP EIGRP neighbors. I have a neighbor, that's good. So router 2, (34, 35, 46). Yeah, so router 2 is as I expected. But I don't think I can understand why. Okay, let's just look at the topology table. Show IP EIGRP topology. I don't see these prefixes in here. Let me see. 68. I see 68. Oh, here's 78. It's passive. The feasible distance is infinity. Why is that? Huh. This is very interesting, is it not? So by looking at the topology table, we see that we've learned the prefixes from router 2, but they're in a passive state. And that's because the feasible distance is infinity. This would be a learning experience for me. Let's look up EIGRP feasible distance infinity. What causes that? Let me just click on both of these. Oh, this is a great blog, guys. I actually don't know the content of this one. I'm just looking at this topic. But this author here, Joel Knight, has really amazing blogs. Definitely recommend bookmarking his blog site here. Really cool. I don't know what's contained in this one, but I've definitely referenced his blog and his work previously. So really awesome stuff. It says, let's take a look at the EIGRP and the state a route can get into where EIGRP tells you feasible distance. First of all, maintains a local database called the EIGRP topology. It holds a copy of every route received from every neighbor and every route being advertised by the local system. Best pass decision process and on the entries in the table in order to determine which routes are the best, and then hands those best routes to the RIB. By inspecting the entries in this table, you can see things like bandwidth, load, delay, the values to go in computing the composite metric, the actual composite metric that the local system has calculated, the composite metric that the neighbors calculated, whether the route is internal or external, a list of all neighbors that advertise the route, the feasible distance for the route, and the metric for the route as seen by the RIB. I've used superscript numbers in the output to indicate whether each of these... Okay, so he's showing for a specific prefix, and then sort of showing what those are. This is the neighbor's router ID. This is number 2, which is going to be the actual composite metric at the local system. So I guess let me throw in one of those prefixes and see what we get. From router 4, let's do this 78 one. Show IP EIGRP topology. Throw that sucker in. Okay, here's the information. ERP topology. State is passive. Origin query origin flag is 1. 0 successors. Feasible distance is infinity. RIB is... Alright, we learned it from router 2. Send flag is 0. Route is external. Composite metric is minimum bandwidth, total delay, reliability, load. The originating router is 3. Okay, that makes sense. External data. Autonomous system number of route is 1. External protocol is OSPF. The external metric is 2. The administrator tag is 0. This is quite confusing, actually. I don't actually dive into EIGRP too often, but I definitely should be able to. The output above is what I call a healthy topology table entry. We don't see feasible distance is infinity anywhere if we check in the RIB. The route is there too, correct. Or feasible distance is entry. Let's analyze this entry. MTU and hop count are created in EIGRP updates, but they are not used in metric calculation. The next hop is on the locally connected interface, is reachable. Perhaps the most confusing is the local composite metric is a reasonable value and is far from infinity. The RIB value is recognized as... Let's just take a look and see what we had. Huh, wait a second. Is it because I'm using named EIGRP here that my values are different? And that's interesting. I wonder if that's the case. Oh, okay, it says RIB is... Let's see what ours says. Yeah, same value. So what's going on here? Unless I'm missing something, there isn't a direct way to understand what this means. Please post a comment if I've overlooked something. Instead, we need to get our hands dirty with our good friend debug. Since we see the route in the EIGRP table, we know that EIGRP update messages are being received successfully. Correct, that's my assumption as well. So we can assume that there's nothing to do with EIGRP updates. We could investigate the EIGRP infinite state machine, or finite state machine. Since I've already done that, I can tell you that has nothing to do with this. I won't go there. Instead, let's debug the routing table to see what it's doing when EIGRP sends it the route. Here's a tip for debugging the routing table. Since the output can be quite verbose, create an access list which matches on the prefixes you want to inspect, and then use that ACL when turning on debug. I'm just reading through this output, trying to decipher what's going on here. Okay, cool. EIGRP has sent to the RIB, and the RIB is actually installing it. That's exactly what we thought should happen. Closer administrative distance. Flushing 1 routes. Oh. I freaking get it. I think I get it. Let me see router 2. Oh my gosh. Yes, I get it. Oh, okay. Man, sometimes this is awesome. This is awesome, man. When you get to discover something, it's awesome. And it's not like something brand new. It's something so basic, but it is so basic. It is, I mean, I'm telling you, it is the simple things that you have to watch out for. That has been my advice throughout my CCIE journey, is foundations, foundations, foundations. You must understand all of the foundations of the protocols and how they interact and everything. Do you see what's going on here? I see it now perfectly. I see it absolutely perfectly. This is awesome. What's happening here, oops, I lost it. Okay, let me bring up the whiteboard, discuss what I've seen, and then I'll show you here in the router configs themselves. That's not what I wanted. This is what I want. Okay, we do see these prefixes. Okay, maybe I'll start off by writing these prefixes. I'm going to particularly look at this 78 one. We'll just look at the 1, okay, because it is the furthest from the EIGRP routing domain. So let me clean up the screen here. We'll leave a check mark there. Okay. On router 3, we are redistributing OSPF into EIGRP. Router 1 and router 2 are only in the EIGRP routing domain. So router 1 only sees prefixes for this network, and this network. And the same thing on router 2, right? Let me just take a step back. Before redistribution, router 4 and router 3 could only see this prefix and this prefix on router 3 for via EIGRP. And the other way around on router 4, because this one is connected, directly connected, we only saw this one and this one via EIGRP on router 4. That's perfectly fine. Okay, so now our next step was on router 3, redistribute OSPF into EIGRP. So we see those updates get sent across, and router 1 populates its routing table, right? Its EIGRP table and its routing table. And it gets all of the prefixes from all of the topology. It gets them all. And because it gets those prefixes and their new routes to itself, it'll go ahead and advertise them over to router 2, and router 2 now sees all the prefixes from the rest of the protocols, right? Then those get sent over to router 4, and specifically we're looking at, you know, things that are far away. And I'm just looking at this one. We could look at this one or this one as well, if you choose. When we look on router 4 via EIGRP, when we look at the topology table, Did I spell it right? Topology? Topology, we see all of the prefixes being learned via EIGRP from this neighbor. Router 2 is sending it, and we're seeing that in the EIGRP table. But what's happening here is, because we're redistributing here on router 3 from OSPF into EIGRP, these routes are being injected into EIGRP as D for EIGRP for Dijkstra's algorithm, external routes. And external routes have an administrative distance of 170. Now that's no big deal here on router 1 because it is the only path it has to get to the prefixes is through router 3. And right here from router 2, that's no big deal because its only path is to send it to router 1, which will send it to router 3. So it doesn't matter that they're external and 170. But when we get here on router 4, when router 4 receives a prefix for this network, which is 10.1.78.0/24, and it receives it via router 2, it says, hey, I see it. I'll put it in my topology table, EIGRP topology, but it will not put it in the routing table because it is also receiving this prefix via RIP, via OSPF. And OSPF E2 is 110 administrative distance, and EIGRP external is 170. So it is not going to install those EIGRP routes. It is going to keep its OSPF routes for that for those prefixes. So let's take a look. I'm going to sort of what I call walk the dog, which is kind of go around the topology. Here on router 1, not end, oh crap. Administrative distance. I'm talking administrative distance is a CCNA level topic. Okay? And here we are sort of getting burned by administrative distance yet again in CCIE. I'm telling you, foundations, foundations, foundations. It is the most important to understand the foundations of networking and how these devices act and react by default. That's the only difference between someone at a CCNA level and someone at a CCIE level. Is at the CCIE level, you understand more about the device, how the device is going to react by default in many more situations. By default. It's not anything special with these crazy nerd knobs that you have to turn or anything. It's how is this going to react when I use the router like this in this situation? Going like, oh, okay, I know it's going to do X, Y, and Z, and that I'll need to do A, B, and C to fix that. And here's exactly a perfect example of this problem. So on router 1, we do show IP route. We're learning our prefixes. Here they are. EIGRP external, right? They're coming from router 1. Or excuse me, they are coming from router 3. Router 3 is doing our redistribution, and here they are right here. Now again, here's the external flags that we see, and their administrative distance is 170. So router 1 is going to take those prefixes that is now in its EIGRP table and send them over to router 2. And router 2 is going to receive those, and as long as it doesn't have anything with a better administrative distance, it's going to install them as well. So here they are. It's the same prefixes learned as external routes, external to the routing domain, with its administrative distance of 170. And here's that one prefix we just wanted to identify. And the best way for router 2 to reach this prefix currently is to go back to router 1, and router 1 sends it to router 3. Router 2 is sending these prefixes to its EIGRP neighbor because they're in its routing table, they're in its EIGRP table. It says, I think these are valid routes. I'm going to send them to my neighbor. Router 2's neighbor is router 4. But when we look on router 4, we see in order to get to those prefixes, router 4 still prefers the OSPF routes. It prefers the OSPF routes because of the administrative distance of 110. Isn't that awesome? So that means if we go back to the whiteboard, so I'd tell you what we can do. We can fix this, and I'm going to sort of walk through that a little bit. Let's go back. This one. Okay, to reach anything in this area, router 1 is going to forward it to router 3, router 2 is going to forward it to router 1, and router 4 is only going to go this way. To reach anything that came from router 4, from the OSPF or RIP routing domains, router 4 is going to go straight into the OSPF domain. Actually, let's just verify it's going to go to router 6 and not over to router 3. Router 4, yeah, it's going to go to router 6. Okay, obviously this one is directly connected to router 4, so it doesn't need to use a routing protocol to reach it. Now for router 4 to reach anything in the EIGRP routing domain, it's going to send it over to router 2, and that's going to be for this network and this network. And that's it. So router 4 should have full reachability right now. However, we can't fully ping yet. And the reason is we never redistributed EIGRP into OSPF on either router. Oh my God, my back, guys. Okay, so what do we want to do here? What do we want to do? What do we want to do? What do we want to do? I tell you what, let's complete our original tasks of doing the mutual redistribution on everything. So let me get on router 4 and redistribute OSPF into EIGRP, same like we did on router 3. And then let me redistribute EIGRP into OSPF on both ends. And then let's sort of see how everything is interacting with one another. So here, let's do, we're in named EIGRP, so router EIGRP lab 1234. We're going to do address family, IPv4, autonomous system 1234. And I think we do topology base. And we're going to set a metric. Nope. Let's do default metric. Let's do 1,000, 100, 255, 1500. Now let's do redistribute OSPF. Redistribute OSPF 1. We already have a default metric. I'm working on ICND 2 at the moment, and I'm happy to learn ahead. Yeah, this is awesome. This is just a great way to demonstrate that here at the CCIE level, we have the same challenges, which is sort of working with route selection via administrative distance. So I'm going to go ahead and hit that redistribute. Now, router 2 should reach the OSPF prefixes via router 4 now. It should have a faster path. Or a path with less cumulative delay. Yeah, so router 2 now flipped to router 4. Router 1 should still be pointing to router 3. It is, and it'll be using, router 1 and router 2 will be using each other as backup paths, as feasible successors. In fact, let's just double check that. I'm going to get on router 2 and see that router 1 is a feasible successor for okay. I'm going to show IP EIGRP. What am I missing here? Interfaces, accounting, autonomous system 1, 2, 3, 4. Interfaces, neighbors, topology. No, it's not going to have a feasible successor. Because in order to have a feasible successor, its reported distance must be less than the feasible distance from its neighbor. But if we do topology all links, we should see 2 entries. So here's our 2 entries, but it doesn't satisfy the, what do they call it? The feasible distance, feasible successor requirements. Eligibility, the feasible successor eligibility. It doesn't satisfy. I like what you said. Foundations are very important. Without having a proper understanding of the basic concepts, it would be very hard to get any certs. Yeah, I mean, it's true. You know, when you see someone who understands the foundations very well versus someone who, you know, just studied enough to pass a cert, there's a shining difference. There really is. And so that's what I have found, that doing a lot of CCIE labs, prep labs, that I find myself getting stuck on things that are relatively simple and that go back to foundations that I've learned in CCNA and CCNP. And that's when I came up to the idea of pushing foundations. You have to know all of the foundations. Okay, all right. So this is not actually, this lab is not actually behaving the way I thought it should. And the reason is I thought I was going to be able to build a routing loop in EIGRP. But because of the administrative distance, I'm not going to be able to, unless we modify the administrative distance. So let's do that. So I'm going to get on our redistribution points. Oh, and you know what? Let me take a step back. I'm jumping ahead. I have not redistributed EIGRP into OSPF yet. Well, let's do that on both redistribution points. So router OSPF1, redistribute, I think EIGRP, what is the autonomous system? 1, 2, 3, 4. We definitely want to do subnets. And I don't know if it will do the external routes or not. Again, this kind of goes back to foundations, the redistribution basics. What will happen by default? By default, how do we cover this? Let's see what happens. I'm going to do it on 4 and 3, give it a minute to cook, and then I'm going to come back and check that show run all. Conft router OSPF1, redistribute EIGRP 1, 2, 3, 4 subnets. Now let me get on router 4. Router 4 is here. Redistribute EIGRP. Do show run all section router OSPF. So I'm redistributing EIGRP metric type 2, right? So it's going to be type 2 with a metric of 20 by default, subnets and tag 0. What I'm interested in is to see if it includes the externals. Sorry, I'm trying to think in my head on whether this will actually work or not. I'm trying to build a routing loop. I'm actually trying to introduce a routing loop, and I'm trying to figure out what is going to be the best way to do that. And every time I think of an idea in my head, I'm trying to justify whether or not it will work and why it won't work. So let's it's becoming rather difficult. So let's see, on router 3, show run all section router EIGRP. No. OSPF. Redistributing EIGRP. Okay. So now if we just go to the end of the topology, which is over here between 7 and 8, let's get on router 8. Router 8 should now see the prefix between routers 1 and 2, which is at the complete other end of the topology, I think. Okay, wow. Okay, this is pretty cool. So it does see it. It also sees our first 3 prefixes. So that means EIGRP is being redistributed into OSPF, and OSPF is being redistributed into RIP. And it's perfect. So now router 8 should have full reachability to routers 1 and 2. We can verify that by doing a ping. Cool. And that's going to router 6 as its direct path. And tell you what, let's do a trace and let's see where these routes are going. Trace route 10, 1, 12, 1. Try to cancel. Control Shift 6. We can do it like this. Thank you. So it's going to router 6, then to router 4, then to router 2, then to router 1. Very cool. Very cool. Now let's change it and we'll reach router 2. Should be the same path. 6 to 4 to 2. And that should be it. Yeah. Okay, very cool. Now let's take a look at router 7. Let's do a trace and see what router 7's path is. Trace 10, 1, 1, 2, 1. Numeric. It's going to 5 to 3 to 1. And we'll try to hit number 2. Okay. Perfect. That's kind of like exactly what we would expect. So if we were to draw this, oops, there goes my pen. If we were going to draw this from router 8, it's going to router 6, then to router 4, then to router 2, and then if I ping the dot 1, it goes to there. And from router 7, it goes to router 5, it goes to router 3, it goes to router 1, and if I was pinging the dot 2, it went to there. So that's pretty cool. That's kind of like exactly what we would expect. All right, while we're here on router 7 and 8, let's take a look at the routing tables and just see what we can see. Show IP route. Like we see we have 2 paths to reach 68. 68 is between router 6 and router 8. And it can go to router 8 or it can go to router 5. Let's take a look at our topology and understand why we have 2 equal costs there. That's not what I'm looking for. So here from router 7, we have 2 paths to this network. One of them is this way with a hop count of 1, and one of them is this way with a hop count of 1. Isn't that very interesting? Let's see what router 5 thinks of that situation. Router 5, what say you? Show IP route to reach 68. Look, it's learning it via OSPF. Now, how about that? So what we have here is actually something far from, absolutely far from equal cost paths. So this is going over to router 3. Oh my God, this is absolutely brilliant. I love this. Let's back it up. Fan on here. Okay, from router 7 thinks it has 2 equal cost paths to reach this network. It thinks that it can forward packets to router 8, which is only 1 hop away, and it thinks it can forward packets to router 5, which is 1 hop away. But when we look at, we can plainly see that if it goes to router 5 is 2 hops to this prefix. But router 5 is not using this link. Router 5 actually thinks to get to this prefix, the 68 prefix, it needs to go to router 3. Which means router 3, I think, let's go to router 3, but is going to send it to 4, and 4 is going to send it to 5 to reach that. Now, router 2 sees it as equal cost paths. Excuse me, not router 2, excuse me. Router 7 sees it as equal cost paths because they both have a hop count of 1. So let's check on router 3 and see how router 3 is going to get there. Here's router 3. Show IP route. We're looking for the 68 prefix. Here it is, OSPF E2, and it's going to router 4, and router 4 is going to send that back around to router 6. So I tell you what, on router 7, let's shut down our ETH00 interface. We're going to do 10.168.6. So now I'm going to do a trace route, right? Because router 7 thinks that it's only 1 hop away, and that it can send it to router 5 because we just shut this down. So I tell you what, before I type this command, I do show IP route. Let's verify we still have a path to 68. It's going to router 5. Sounds good. All right. Oops. Do trace 10.168.6 numeric, and you see it's going to router 5, to router 3, to router 4, to router 6. But it sees that as being only 1 hop away. Right, and the reason it's doing that when we did the trace route, it goes boom, 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 all the way around. The reason it does that is because right here, when OSPF gets redistributed, into RIP, we're setting the metric value to 2. Excuse me, we're setting the metric value to 1. So when that gets sent over here to router 7, it sees that, wait a second, this prefix, which I've learned from OSPF, it comes all the way around this way, is really only 1 hop away. Which is really not true, and is just sort of I guess maybe a symptom of being redistributed. So next, what I want to do is something even further than this. Here's what I want to do. I should have just cleared the screen. Clear. I'm going to re-enable this interface on router 7. I'll do that in just a moment. Now, actually, you know what? I'm gonna leave this interface shut down. Excuse me. I'm kind of just figuring this out right now. And in order to reach this network, I want it to traverse routers 5, 3, 1, 2, 4, and 6. So I actually want it to go like this. Right now, we see it going like this. Right? Does anyone out there have an idea on how to do this? I have an idea. I think I can do it, but I'm just curious to know what anybody else thinks. So if I get on our redistribution points of 3 and 4, which is where we redistribute OSPF into EIGRP, I'm going to go into router EIGRP 1, 2, 3, 4, and I'm going to say EIGRP. Nope. I'm going to say distance, EIGRP. And I'm going to do this on router 4. Show, no, not show. This is going to be conf t. Remember, we're in named EIGRP. Router EIGRP lab 1234. And this is going to be, is it in topology base? Oh, excuse me. Address family IPv4 autonomous system 1234. Topology base, and we're going to do distance EIGRP 9090. All right. Route configuration change, new adjacency. Okay, so we got that bounce there. We got that bounce on router 3, which means router 1 and 2 should be ready to go. Show IP route. That's not what I expected. Show IP route. That too is not what I expected. Let's see what routers 1 and 2 look like. What's going on here? Routers 3 and 4, I would expect. Yeah, I would expect this to look differently. So internal 90, external 90. Show IP protocols for EIGRP. Distance internal 90, external 90. I would expect that those redistributed prefixes from OSPF into EIGRP let me think about why this doesn't work. I think it's because of split horizon, actually. I think it's because of split horizon. I'm making a prediction. I'm not sure. Let me kind of bring up the whiteboard and sort of walk through what I think is going on here. Wow, this lab is just providing layers of depth, and this is awesome. So much to do here. Okay, this is still shut down, so we want router 7. Currently, router 7, if we trace route to this prefix, goes like this, and we've already identified why that is. What I want to do is force it to go the really long path. And so I thought by changing administrative distance on 3 and 4 would do that. And so what that means is when we redistribute OSPF into EIGRP, it gets a 170 administrative distance. It gets a 170 administrative distance. Or I guess rather, when these prefixes get received, they're there, and here they're received because they're external routes. Maybe that's a better phrasing. When they're received because their source is external, they have a 170 administrative distance. But because router 3 is also redistributing OSPF, it's sending them to router 1. And router 2 is sending them, router 4 is sending them to router 2. So what that means is when whoever was first, when they send an update this way, router 1 will never send it this way. And if router 1 sends an update, router 2 will never send it this way, because the split horizon rule says a router will not advertise a prefix out the same interface that of which that prefix was received. So we're both sending each other the same prefixes. So router 2 is receiving it from 4, and it will not send it back out to 4. That is the split horizon rule. Now, can we break this by turning split horizon off? How's that for a crazy lab? Guys, I gotta go do some back exercises or something. This is crazy. No. No IP, EIGRP. Now I'm also going to do it on 2, but that's a named configuration, so it's a little bit different. Show IP interface brief. I'm kind of glad I did it this way, the 2 interfaces. So let's do conf t router EIGRP 1, 2, 3. Nope. Lab 1, 2, 3, 4 named. Address family IPv4. Autonomous system 1, 2, 3, 4. Address family interface. No split horizon. Cause router 4 to resync. So what I was expecting to see was, I was expecting to see the prefixes to things from the RIP routing domain to go back to the EIGRP neighbor. That's what I'm expecting to see. That's what I'm trying to create. Show IP route. Ugh. I think we're going to have to do some debug. And they're still coming in as OSPF. I would have expected these to have changed. Let's do debug IP. I would have expected to see some more debug messages than that. Weird. just sort of examining the routing table here. Well, all right, so let me turn off and let me do a debug here. IP EIGRP on router 4, 1, 2, 3, 4. Okay. Okay. Just had to step up for a minute and stand up, straighten my back. Got this terrible headache still. Okay, let's do clear. I kind of just want to see what router 4 does with the clear IP EIGRP neighbors. I want to see what router 4 does with those prefixes, if it even sees them. So I see here there's a debug entry that says do not advertise out. I think that is the split horizon kicking in on router 4, of which I didn't turn it off because I don't think I need to turn it off there. Okay. How can I create that loop? If I'm on router 4 and I do show IP route, it's still preferring OSPF. But router 2 is not advertising it. Ugh. Router 2 is not advertising it to router 4. I guess we need to get back onto why is router 2 not advertising it to router 4. So I think what I'm going to do is I'm going to kill the redistribution on router 4 of OSPF into EIGRP. This says do advertise. Did I see don't before? Here we go. Okay, that is very interesting. Very interesting indeed. So I think I'm able to implement what I want, but sort of why is it working? I don't know. I can see now that our administrative distance is 90 for external routes, right? Because we changed that value. But why weren't I receiving those routes previously? I think it was because of router 2 wasn't sending them. But why wasn't router 2 sending them? Maybe router 2 and router 1 weren't sending them to each other. How about that? I feel like this should work, so I'm not done pulling at this thread. Oh, that was the wrong interface. Named EIGRP, and then we'll do address family IPv4 autonomous system 1234. Got it. Now we'll do no, we'll do address family interface ETH00, and we'll do no IP split. How about no split? I know that's a little crazy. I think it's a little crazy myself. I'm not exactly sure what the source is here. Actually, I want to reintroduce the redistribution of OSPF now. So I'm in named EIGRP on this router. So router EIGRP lab 1234. Address family IPv4 autonomous system 1234. And let's do topology base, and let's do redistribute OSPF 1. I already have a default metric, so there we go. What is this? Exists? State machine. What is this? Exists? I don't think I've ever seen this before. Exits or exists? The metric. 4634. Okay. Okay, so this is routing to router 2 for 78. If I go to router 2, that's routing to router 1. Router 1. To get to 78 is doing 3. And where the hell is router 3? That's going to 4. Okay, so we do have our loop. Wow, this is nuts, man. Although it is completely backwards from what I want. Let's look at 68. Show IP route. We were looking at 68. 68 is going back to router 2. Why isn't that happening? I'm trying to think why this isn't working. So let me get on router 7. Let me see if I can no-shut that interface, I think. I don't know. So my ping is going to come from 10.1.57. I'm just trying to think what is the cleanest way to do this, and I think I'm sort of running out of ideas. I think the only way to do it is like dirty, which is like creating like a route map or something, and just modifying the distance or the metric for just a single prefix. I want to know why router 4 Alright, so let me flip the script on router 7 and 8. Show IP interface brief. CompT interface. Try one more time. CompT interface. Boom. No shut. Router 8. Show IP route. Just Ethernet 00. CompT interface. No shut. Not no shut. What a waste. Interface Ethernet. Shut. Did I do the same thing there? Let me see. Show IP interface brief. Administratively down, router 7, and show IP interface brief. Alright, no shut. Alright, so for show IP route. Crap. Alright, there's the 78. It goes to 68. Alright, let's do a trace. 10.178.7 numeric. Isn't this interesting? What the bloody hell? Okay, E2 via 4.6. I'm with you. Show IP route. 78. Okay, goes up to router 2. Okay, I'm with you. 278 goes to router 1. Router 1. 78 goes to router 3. Router 3. 78 goes to router 4. That's the problem. Okay. There is a routing loop here. And so if we try to do it here, trace route 10.178.8, we should see it's, oh crap. We should see a giant routing loop. Yeah, see, immediately. Routing loop goes between 4 to 2 to 1 to 3 to 4 to 2 to 1 to 3 to 4 to 2 to 1. Wow, this is becoming very challenging, as a matter of fact. I thought this was going to be a little bit easier. So we still haven't solved the problem there. So what I want to do is get on routers our other redistribution points, which if I look at the topology, whew, I'm starting to get tired. Let's look at these guys, 5 and 6. And we're going to mess with the redistribution there. Or rather, we're going to mess with the administrative distance there. 5 and 6, if I can. This is going to be a RouterRip. The administrative distance. Source address. Anything. Actually, I think we'll just do distance 109. We should be good to go. Number 6, 5 and 6. RouterRip. It's a little bit different problem than I was working before, but what I'm doing here is trying to lower the administrative distance of RIP routes to be below OSPF, so they'll be preferred internally. And that's so I think that'll help us a little bit. So 3578, that's going back to, let's see if I'm on router 6, it's going back to router 5. So now I just did a trace route. What's going on here? This is one crazy looking trace route. Let me kill it and take a look at what I'm looking at. So it looks like from this router, router 3, we have 2 paths, which is to router 4 and to router 5. And the second hop is between router 7 and router 2. So why does router 3 think it has 2 paths? Show IP route. Okay. Because the metric value is the same on both of those. These E2 routes are coming from the RIP routing domain, and because we're redistributing them as external type 2, the metric values don't change as those prefixes move throughout the OSPF routing domain. So they're all going to retain a metric value of 20, which essentially on any router that receives 2 of the same prefix is going to think it has an equal cost path if it comes from different neighbors. That's what I'm putting together here now. So that looks correct. If I'm on router 3, it thinks to reach anything in the RIP routing domain is to 4 and 5. So if I'm here, to reach anything that is in this block, router 3 thinks it has a path this way and a path this way. Okay. Let's see what router 4 thinks. It's still learning its prefixes via EIGRP. So what I'm wondering here is, if I get on routers 1, 2, 3, 4, 5, and 6, routers 5 and 6, that's RIP. What if I do, what was I thinking? OSPF. If I get into router OSPF 1 and then go redistribute RIP subnets metric type 1. And then I get on 6. Router OSPF 1, redistribute RIP subnets metric type 1. And that means it'll have an increasing metric as it gets passed through the routers in the RIP routing domain, which I would think over here on router 3, that'll break this equal cost path that we see here. Yeah, it should have only one path, right? Whichever one is the best. Here are the routes now, E1s. It's going to router 5. Let's get back to our drawing. Let's just kind of map this out, what we see. All right, router 3 is now forwarding to router 5 for anything that is destination for the RIP routing domain. Let's check on 4. Router 4 is sending everything to router 2. Router 2 sending it to 1. Router 1 sending it to 3. So again, let's draw that on our map, on our little network map. So from here, we're sending to this way. It's being sent this way. It's being sent this way. Let's take a look from router 5 and 6's perspective. Router 6, show IP route. For example, 78 is going to router 5. 57 is going to 5. 68 is directly connected. Let's look at router 5. Show IP route goes to router 7. 68 goes to router 6. Okay, so I think I'm ready to try a trace route, and I'm going to tell you what I think is actually happening. First, let's do the trace route because I'm pretty anxious about doing it. All right, I'm going to trace route to 10.178.7, which I know is connected to router 7. Router 8's interface is down, numeric. And this is going to be sourced from the local interface, right? So let me show the interfaces. Show IP interface brief. We're going to be sourcing from this interface, destined for the other side of this link. So trace route 10.178.7, source 10.168.8, and numeric. All right, 6, 5, and 7. That's very interesting. 6, 5, and 7. I did not expect that. Let me trace that out and see where that's going. I'm on router 8, so I just initiated a trace. It goes to 6, it goes to 5, it goes to 7. I did not think that 6 was forwarding that prefix to 5. But perhaps I just overlooked it. It is forwarding it to 5. I'm going to try and modify administrative distance one more time. RouterRip, no distance, 109. I hope I'm getting to be at the end here because my headache has not gone away. At least my body temperature is normalized. I don't feel hot or sweaty or too cold, although I am getting a little bit cold. But I'm glad at least I was able to focus on this lab. This lab has been a lot of fun. You know, it's a little bit different pace for me. Normally on Sundays, I like to do long labs, you know, pre-built labs either by Cisco or INE or Narvik workbook, any of the workbooks that I have that I can work on. I typically try to do on Sundays. But I wasn't feeling well today, and so I didn't want to commit myself to 6 or 8 hours of a lab that I might not be able to finish. So I thought I would just dive into something that I was sort of thinking about the other day with, I've been doing a lot of redistribution because I've been getting stuck on that in labs. So I thought I would just sort of dive into it today. And all right, here we go. This is what I was looking for. So I wanted to see that this prefix is learned via OSPF. Okay. Let's try again. Router 8. Here we go. For the win. Pray for me. Here we go. Sweet. Now, I think there is something else happening here. 5, 6, 7, 8. On router 5, for example. Yeah, okay. So this is a trace route that I was trying to get. Okay. This is the trace route. So if we do a screen sketch here, I'm on router 8, and I'm trying to reach the interface on router 7, sourced from my interface that's in between router 6 and 8. And I see my traffic going 6, 4, 2, 1, 3, 5, 7, right? So if we remember that, 6, 4, 2, 1, 3, 5, 7. All right, let's clear our board. This interface is shut down on router 8. So the only way to get to this prefix must be another way. We're sourcing our trace from here. And remember, it was 6, 4, 2, 1, 3, 5, 7 to get to this interface. So that means our packets are taking really the long way away. Now, there definitely wasn't a I don't think a single way to do this, and definitely I just ultimately ended up just turning enough knobs to make this work. But this was sort of a good lesson for myself in understanding sort of the default behaviors between the interaction of routing protocols and multiple redistribution points. So if I take a step back for anyone who's just joining me, this is a RIP routing domain. This is OSPF. And this is EIGRP. And so this was just a great lesson in sort of exposing what are sort of the default behaviors and some of the challenges when we're doing redistribution in between protocols at more than one point. This is something I did on stream the other week, maybe about 2 weeks ago. And at that time, it was only between RIP and OSPF at 2 points. So I wanted to take it sort of a step further and introduce another routing protocol in there. And I'm glad I did, because it was very educational on that. So the only interface that I have shut down in this whole thing is this one. And that's so router 8 doesn't try to ping router 7 because it's directly connected. And so that's relying completely on routing protocols. And what I ended up doing, if I try to recall everything, I turned off split horizon on these two interfaces. Because one of the challenges that I was seeing was, as router 4 advertises to router 2 and router 2 sends that advertisement to router 3, this is 4, 2, and 1, as it advertises northbound from router 2 to router 1, router 1 already received the same prefixes via router 3, so it will not send those out router 3. And the same thing could be said. Router 1 was receiving them from router 3 advertising this way or not, right? If it already received them, it kind of becomes a race condition at that point. And I think that was something that I wasn't seeing. And my phone is going crazy. Sorry, I was reading something off to the side. That's one of the great things about never really being focused. You get to focus on so much at one time. So I think originally I turned off split horizon only on the interfaces facing router 3 and router 4, and that did not do the trick. And I think it was because I was falling victim to the split horizon rule in between these two routers. So once I turned it off on these two routers, what I wanted to see, what I expected to see, was router 3 send prefixes up, router 4 send prefixes up, and then I wanted each one of them to install the received prefixes in their routing tables. And I was able to do that by lowering the administrative distance of an EIGRP external route, which is indicated by DEX, which is default 170. I lowered it to 90. So it's the same as an internal. So once I did that, because if I did not do that, what was happening was the routes I was learning via OSPF take here on router 4, The routes I was learning via OSPF have an administrative distance of 110, and anything that was been sent from router 3 to router 1 to router 2 to router 4 had a 170. So naturally, router 4 was always going to install the 110 routes and basically just ignore the OSPF, the EIGRP routes. So once we lowered the administrative distance to 90 for external routes, that made routers, the two redistribution points. I'm trying to erase everything except for everything. That made the two redistribution points here on 3 and 4 install each other's routes with an administrative distance of 90. Except I think, again, if I'm looking back and I'm trying to think about the logic of all of this, router 4 is not going to advertise out the prefixes that it just learned from router 3, right? Because of split horizon. Not unless I turn off split horizon here. So I think in order to really receive dual prefixes, which again would actually create a crazy routing loop, would be to turn off split horizon on all of the interfaces, right? Because that's how split horizon is a loop prevention mechanism, right? It prevents the loops. But when you're trying to create a loop, you need to disable split horizon at some points. So once we were able to do that, OSPF, what I did here on router 5, because what was happening here was on routers 5 and router 6, they were both redistributing RIP. Let me try and erase all this junk so I got a little more writing room. Router 5 and router 6 are both redistributing RIP into OSPF. Those OSPF advertisements are being circulated around, and what's happening is one of these routers, it could have been router 6 or router 5, I forget which one, will actually be installing the OSPF routes to the RIP routing domain. And what that means is for router 6 to get to this prefix, it's actually going to go this way. It thinks router 4 is better because of the OSPF administrative distance of 110 versus the default administrative distance of RIP, which is 120. So how we got around that was to make sure that we lower the default administrative distance on both of these, router 5 and 6, from 120 down to 109, which basically tells router 6 and router 5, hey, anything that came from the RIP routing domain, prefer the RIP neighbor, right? It could even be this way, prefer the RIP neighbor, and don't prefer it via the redistributed, protocols. And then lastly, what I did to make this giant suboptimal routing example was I actually raised the RIP default routing domain from 109. I raised it up to 120 here on router 6. Okay, once we did that, what we had was I shut down this interface on router 8. And I tried to ping the IP address that rests on this interface, which was 10.1.78.7/24. It was no longer reachable this way because I shut down the interface. So the only way it could go was here. And it goes to router 6, router 4, router 2, router 1, router 3, router 5, and router 7. But, the return packet of those trace routes are returning like this. They're going from router 7 to router 5, and router 5 says, oh, router 8's interface, that's this way. And router 6 obviously sees it as directly connected and forwards it over to router 8. Now, let's check that trace route again. Trace route 10.1.78.7. I'm going to source it from 10.1.68.8, which I don't have to put the source statement because I only have one interface left. I'm going to use the numeric statement so it's not trying to resolve anything. When I hit enter, you see it go 6, 4, 2, 1, 3, 5, 7, right? It's taking that long way around the topology. However, the return path, so if we just kind of like walk the dog, this is a saying I use all the time. On router 6, let's do a show IP route. Let's look at the destination and let's look at the source. The destination is 10.178, and that goes to router 4. The source is 10.168. It's directly connected. Nothing unusual there, right? Let's jump to router 4, which is our next hop for the destination. Show IP route. Let's look at the destination. It's learned via EIGRP external. It's being sent over to router 2. And the source is also being learned from router 2. So isn't that strange? That is a little strange. Let's go to router 2. Show IP route. Let's look at the destination, EIGRP external. We're learning it from router 1. And the source is also being learned from router 1. Okay, okay. I'll tell you what, let me keep a running log of exactly what we're looking at here. Okay. I'm going to use black for the destination. And I'm going to use red for the source. And here's what I mean. On router 8, to reach the destination, it goes to router 6. On router 6, to reach the destination, it goes to router 4. On router 4, to reach the destination, it goes to router 2. Now let's show what direction our sources were. Our source starts here on router 8, so router 8 sees itself. On router 6, it shows that it's directly connected. On router 4, it says, hey, the source is actually up here to router 2. And on router 2, I believe we just looked at that. Let's verify. Router 2, the source says it's over on router 1. This is truly, truly an amazing lab. So router 2 thinks that the destination and the source are both towards router 1. Let's get on router 1. Show IP route. The destination is towards router 3. And our source, from router 1's perspective, is also towards router 3. Let's put it on the map. All right, so here we are. Destination is router 3. Source is router 3. Let's get on router 3. Okay. On router 3, we can see that the destination is towards router 5, and so is the source. Let's put it on the map. I think it's just best that I hop back and forth in between each hop. Now let's get on router 5. After this, guys, I think I'm going to wrap it up. Go take a lunch. And I don't know what I'm going to do for the rest of the afternoon, but I'm not really feeling well. I got to take care of a couple of house chores. But I'm hoping to wrap this up in the next 30 minutes, and then I'll probably wrap up stream for the day. You guys might see me online on Discord. If anyone wants to join the Discord server, there's a link in the description below. That's where we got all the good happenings, a lot of good networking chat, a lot of stuff going on there. Some days are a little less chatty than others, but always some good info. And as always, you can follow me on Twitter at ShowIPInterfaceBrief. If you like this video, remember to subscribe to the channel, tell your friends, tell your auntie, tell your uncle. And remember to hit the bell if you want to catch every time I go live. There is a fair warning, I go live sometimes beyond midnight. So a lot of times I do late night streams. But here's a little look into my crystal ball. That may change in the future. I may be looking to do some early morning labs We'll see. I've talked about it with my family, so we'll see how we're doing. Router 5's perspective. To reach our destination, looks like we have 2 equal cost paths, which are going to router 7 and router 6. And our source is towards router 6. So let's go ahead and put that in. That was 7 and 6 and 6. No, not that, not that, not that. Oh, crap, I lost my history. Ah, you bum. Crap. I lost my my drawing. It's alright, I'll do a new one. I'll just quickly sketch on what we were seeing. So I was using this for destination. I was using red for our source routes. And so our destination went from 8 to 4 to 2 to 1 to 3 to 5 so far. And our source originated from router 8. Router 6 sees it this way. Router 4 sees it this way. Actually, I should do these on the inside. Okay. Right there. And also, this interface is shut down, which I'm going to do in black. I can't do this. I'm struggling to get the right color on the screen. Black, I say. There we go. Okay, so the destination from router 5's perspective was 7 and 6, so which means it's going here and going here. And the source from router 5 is going this way. So we have one last router to do, which is router 7, and I hope I don't screw up my drawing. One last router to do, router 7, where you at? Show IP route. Our destination is directly connected, right? Because it is on router 7, and our source is a RIP route going back to router 5. Let's put that on the drawing, and I think this will kind of come full picture now that we've walked the dog. I thought I lost my drawing again. Okay, I'm on red, so let's mark the destination. The destination is right here. This is the destination. And the source, to get back to 10.168.8, is back this way. Okay, so how cool is that? Hey, sweet, at this plus that. Let me see, Land Tamer. Wow. So nice of you to grace us with your presence today, sir. It might advertise the next hop as a successor to where router originated, I believe. I have to check that link out later, so I'm just catching up on some chat here. Tony E, coming through my speakers, saying hello. I'm about to go look up your recent Redistribution Lab, RIP Anomaly, and do it myself. Yeah, it was a good one, and actually, I think if you follow the stream afterwards, it's where I actually sort of solved that one. And I'm not sure if I solved it 100% in that one, but I think maybe I give a little tip in the next video. It was sort of something that I was just following for a couple of days. And I don't think I've gone back to that topology, but I definitely have the theory solidified now on exactly what was causing some of the anomalies that I was seeing. It was very cool. Now this plus that, I'm about to lab what you're doing in your most recent lab about redistribution, the Land Tamer. That's sweet. That one's based on the one from network lessons, but from the redistribution problem I found was one I found just trying to find new ways to break it. Oh, okay, I'll need to watch the rest of it. That's kind of what I'm doing here, just trying to find a way to create a routing loop and how to break a protocol a little bit. So anyhow, so if I get back to what I've seen here, so basically we've checked the routing table on every router, and we've marked the direction of the next hop for our destination and our source. Our destination is in black and our source is in red. And what this means is, when we did the trace route packets actually go from 8 to 6 to 4 to 2 to 1 to 3 to 5 to 7. And then the return packet goes from 7 to 5 to 6 to 8. right? Because if you're following the black path to the destination and the red path to the source, right? Isn't that pretty neat? And actually, what's going to happen here, I do believe, is we're going to have somewhat of a routing loop, because you see we have a destination this way and a destination this way. So I think what's going to happen is the first time we trace route, it's going to use this path to router 7, and the next time it's going to send it this way. And then the next time it's going to hit this way, and the next time it's going to get this way, right? And we're going to have this sort of loop because the black path, the destination, sort of forms this loop here. So I wonder if I do multiple trace routes, will we end up with that? From router 8 is where we originate this traffic. We're going to trace route 10.178.7, source 10.168.8, numeric 642.1357. It's the same there. I would have expected some sort of load balancing across on router 5. So I guess let's go back and check router 5 there, see what's the deal. Router 5. See, we have this this sort of equal cost path here, and this is here because it's being redistributed from OSPF into RIP, and we set a metric value of 1. So whether it's learned natively via RIP or redistributed into RIP, there's no differentiation, and they both have the same hop count, which is why we see that. So if we do IPsef for 78, has 2. I think we can do show IPsef. Crap. Per destination sharing. Yeah, traffic share count is 1, and traffic share count is 1. Maybe the land tamer knows. Land tamer, are you out there? How can I tell how much traffic has been shared across when I have an equal cost multipath or equal cost paths? How can I tell how many packets went on one and how many packets went on another? I thought it was going to give me here in the traffic share count. Maybe it's details. Let me see if I have anything extra. No, not longer. Show IP route. Nah, crap. Yeah, I can't remember if it was the CEF table or the routing table. I thought we could actually see the share, but really we're seeing the share count, which is not what I'm looking for. Looking for, like, I guess we could clear the packet counters, but I know you can look at future routing distribution. I think I don't have an answer to that, other than doing packet counters, but then those are going to be unreliable because there's additional protocols and other traffic going on. So I'm not going to see just the packet counters from just that destination. It's a variant of show IPsef. I thought it was show IPsef. Let's see what our options are. Prefix. We did the prefix already. Let's see. Detail. I did. Exact route. Summary. Switching. Okay. 10.178.1. The details not giving me much of anything. Okay, well. 2 hash buckets. I don't know. There was an I&E lab for this with EIGRP. Checking that now. Yeah, I appreciate it. I can't recall off the top of my head. But guys, I think that this about wraps up my lab for the day. Yeah, I think that's going to wrap up my lab for the day. I'm trying to think, is there anything else I can add on top? And at this point, I'm so tired and hungry, there's nothing I want to add on top. Not unless it's a sandwich. So here's what we were looking at. What I was thinking about was, what if I make it so the return traffic, that is the going back to the source, if it did not go this way, instead if it did the exact same return path. But I think that would sort of show IPsef prefix internal. I'm going to take a look at that. I just did that. Land Tamer, and I did not get the results I was expecting. But I was thinking, even if I didn't have this return path, it means I would have to manipulate the routing protocol to completely reverse its path through all of these. And I guess I could do that, but frankly, I'm just very distracted because I want to eat and I'm not feeling well. So I just want to get out of here. It'd be like that sometimes, man. You know, you put everything you got into a good lab and you try to learn and grow, and all I want to do is get out of here. Shows future redistribution of packets. So I did that here. Let me pull that up here on router 5. Here it was, right here. Show IPsef, the prefix internal. Reference count 5, per destination sharing, source is the rib. Hash buckets, 2 hash buckets. But it's not telling me. What I wanted to see was how many packets have gone each way. How many packets have gone for each one. So maybe I'm misinterpreting this output, but I just don't know. So so guys, this sort of concludes my stream for the day. Just because I'm not feeling well, so I'm not going to be doing a long lab. I'm going to go get something to eat, and hopefully I feel better. I'll be back on Monday night doing a normal evening stream. So anyway, let me read what Land Tamer's saying here in the chat. So with 2, that means half and half on the interfaces listed. Yeah, for pass traffic, that is something else. Let's see, for the two hash buckets. Okay, yeah. Yeah, I mean, I figured that it was because the load share, when you do show IP route, you put in a prefix and you detail, if there are multi-paths, if there are 2 equal paths, it will give you the load share, and that's how that's sort of defined, I think. That's where that comes from. But I couldn't figure out exactly how to get the packet count other than looking at the interface counters, and that's not going to be accurate for what I wanted to see. But anyhow, I'll be back Monday. If you guys like this stream and like the lab, please subscribe below. You can join us in the Land Tamers Discord server. There's a link below. It's good for 24 hours. If anyone needs another link, you can go ahead and message me, and I'll send you an additional link. And that's about it for today. I think next week we've got some exciting things coming on. We got lots of more labs, lots more technologies to dive into, and some cool stuff coming up. So thanks for joining me on stream, everybody, today. I really appreciate it, and I will see you all tomorrow.